right, so the fundamental counting principle, what it is there's a couple of ways that you could do it, but the fundamental counting principle is pretty much a shortcut. So for a trip, you pack 3 shirts and 4 pairs of shorts. How many different outfits? So in general, you are going to use the fundamental counting principle if you see different and outcomes is usually a big buzzword. Okay? Those two mean, okay, how many different ways I can do something. So here, different outfits can be done. So you could actually sit there and you could draw it. All right, so I've got 3 shirts, and then for each shirt, I have 4 different shorts. So I have a possibility of, and there should be actually a short here. I guess it didn't get, whatever. I technically have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there's one over here too. 12 outfits, right? Because I could do this green with the white. I could do the green with the striped. You wouldn't look that good, but you could, and so forth. So there are 12 different outcomes. The easier way is just to use the fundamental counting principle, which says that you take whatever it's talking about, multiplying it by the other option, and that gives you all the different combinations. So for instance, we're talking about shirts and shorts. Once again, we're going to multiply. So I've got 3 shirts times 4 shorts. Therefore, I have 12 different outfits. Okay, here's another one. So it says a restaurant serves hamburgers and veggie burgers. The condiment choices are lettuce, tomato, pickle, onion, and cheese. How many different ways can the burger be made? So once again, we have 2 different kinds of burgers. We have a regular burger, and this one's our veggie. So this is regular, this is veggie. On each one, we have 1, 2, 3, 4, 5 different condiment choices. So if I looked on here, each one has 1, 2, 3, 4, 5 condiment choices. Once again, I could just count each one out, or I could use the fundamental counting principle. So over here, we're talking about different kinds of burgers and condiments. So there are hamburgers and veggie burgers. That's 2 different kinds of burgers. Times condiments, I already outlined them. 1, 2, 3, 4, 5 different kind of condiments. So 2 times 5 is 10 different ways the burger can be made. Next one. All right, you are ordering a 1-topping pizza. Okay, that's big. 1-topping pizza. You can have pepperoni, olives, sausage, onions, or peppers. You could also order a small, medium, or large. There are also different types of crust, thin, deep dish, and stuffed. All right, so the first thing that we're talking about, let's just use the fundamental counting principle, are toppings. Okay, then you have the different sizes and the different types of crusts. Now I've just count them out. So for the toppings, I have pepperoni, olives, sausage, onions, or peppers. So 1, 2, 3, 4, 5. Times for sizes, I have small, medium, or large. So 1, 2, 3. Times crusts, I have thin, deep dish, and stuffed. So 1, 2, 3. Multiply that all together. 5 times 3 times 3 is 45 different types of pizza. Next one. The letters A, B, C, and D can be used to create a 3-letter code for a lock. Each letter can be repeated. What is the total number of 3-letter codes that can be made using these letters? All right, if you think of a lock, here's a little lock, padlock, I don't know, right? And then this one, it says there are 3, it's a 3-letter code. So I've got on here 1, 2, 3 different letters, right? Okay. Each one can be repeated. So I could have AAA, ABA, whatever. So for each slot, I've got 1, 2, 3, 4 choices. Therefore, I've got 4 choices for my first because I can get A, B, C, or D. I could do A, B, C, or D there, or A, B, C, D there. So therefore, I put that in my calculator. 4 times 4 is 16. 16 times 4, I believe, is 64. Excuse me. So you have 64 different types of combinations for that lock. Next one. 7 dice are rolled. How many possible outcomes? So I've got 7 dice. So I've got dice number 1 times dice number 2 times dice number 3 times dice number 4 times dice number 5 times dice number 6 times dice number 7. Okay? Each dice, if you look over here, has 6 faces, right? 6 faces. So each one has 6 different faces, so 6 different possible numbers per roll. Now, every time you roll it, it starts over. So each time I'm multiplying. All right, so I need to do 6 times 6, 7 times, so 6 times 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6, and one more, giving me this large and in charge number. So lots of different combos. Okay, that's why Vegas always wins. There's tons and tons of combinations. Alrighty, Burton randomly dials a 5-digit phone number. So I guess we're like in England or something, I don't know. The digits 0 through 9 can be used. Find the total number of outcomes. All right, so this is 5 digits. So 1 times 2 times 3 times 4 times 5. The biggest problem where people say 0 through 9 is 9. It's not. If you count it on 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's actually 10 different numbers. That's 10 numbers. Therefore, there are 10 different numbers. Now it says they can be used. They can be repeated. So I'm just going to fill in 10 every single time. So I put that in my calculator. And I have 100,000 total numbers, total phone numbers. And that makes sense, right? We all have a different phone number. So if it's only a 5-digit, well, there you go. And I think this is the last one. Using the letters PANTHER, a 4-letter code was created. So a 4-letter code. So 1, 2, 3, 4. Okay. What is the total number of 4-letter codes if each letter cannot be repeated? All right, so Panther, 1, 2, 3, 4, 5, 6, 7. Those are 7 different letters. Okay, so I can use any of those letters, but it cannot be repeated. So for instance, if I used P for my first letter, I can't use P ever again. So then it goes down to 6. Let's say I had PA. Well, I can't use PA again. So now I only have 5, and so forth. That's only if they cannot be repeated. If it said they could be repeated, then we would do 7 times 7 times 7 times 7. But this time it's not. So I do 7 times 6 times 5 times 4, giving me 850 different combos. Alrighty. Here are your practice problems. There are 5. I need to see all of your work.